In this video, we're going to be covering how to find and verify inverse functions. So first of all, what is an inverse function? So the inverse of a function undoes the actions of that function and vice versa. For example, if we have x squared here, what function undoes that? Well, that's obviously the square root of x. And if we have the square root of x, what can we do to the square root of x to get back to x? We would square it, and that's x squared. So that means that x squared and the square root of x are inverse functions. And the inverse of f of x is denoted as f of x with a little exponent of -1 here. And we can write our previous relationship as if f of x is equal to x squared, then the inverse of f of x is equal to the square root of x. So let's try some to be exercises here. What is the inverse of x plus 1? Okay, so we have 6 plus 1. How can we get back to 6? We would subtract 1. So that means that our inverse is going to be x minus 1. Okay, for next one. What is the inverse of 5x? Okay, if we multiply a number by 5, like 5 times 6, how can we get back to our original input, which is 6? We would divide by 5, which is the same as multiplying by 1/5. So therefore, the inverse function is 1 over 5x, or x over 5. Okay. What is the inverse of x cubed? Okay. If we have 2 cubed, how can we get back to just 2? Okay, we can do that by taking the cube root. And this cancels out, this cancels out. We're left with just 2. So therefore, the inverse of x cubed is the cube root of x. Okay, so now if we're finding inverses algebraically, let's take our example, x squared plus 1. And let's say if that's equal to f of x, how do we find the inverse? Okay, first, let's replace f of x with just y, since that's easier to work with. X squared plus 1 is equal to y. Okay, and this is a crucial step. We're going to switch the x and the y. So we're going to have y squared plus 1 is equal to x. And what we're going to do now is solve for y. Okay, and to solve for y here, we have to get y by itself. We can do that by subtracting 1 from both sides. Y squared is equal to x minus 1. And now we can take the square root. Y is equal to the square root of x minus 1. And once we isolate y, that's our inverse. So we can write that as the inverse of f is equal to the square root of x minus 1. Okay. Let's apply this algebraic method to some more problems. Okay, so we have y is equal to 4x plus 2. Let's find the inverse by switching the x and the y. So we have x is equal to 4y plus 2. To get y by itself, you have to subtract this constant. So we have x minus 2 is equal to 4y. And now we can divide both sides by 4. I'm going to have x minus 2 divided by 4 is equal to y. So that means our inverse function is x minus 2 divided by 4. What is the inverse of 5x squared plus 6? Okay. Y is equal to 5x squared plus 6. Switch the x and the y. X is equal to 5y squared plus 6. Subtract the constant. X minus 6 is equal to 5y squared. And before we take the square root of both sides, we have to divide both sides by 5. X minus 6 divided by 5 is equal to y squared. And now we can take the square root. The square root of x minus 6 divided by 5 is equal to y, and this is our inverse function, square root of the quantity x minus 6 divided by 5. Okay, now for the final exercise here. What is the inverse of 1 over x? Y is equal to 1 over x. Now we switch them. X is equal to 1 over y. And here we do a rather rare operation, and we take the reciprocal of both sides. So we just flip both sides. 1 over x is equal to y. And here we have a rare case of a function that's its own inverse. Okay, time for verifying inverses. So since an inverse undoes the action of its original function, and vice versa, we can use composition to verify. So for these problems, if we did x squared, and we think the square root of x is our inverse, we have to try taking the square root of x squared, and if that's equal to x, that passes the first test, and then we try it the other way. So we're going to take the square root of x, and then square that, and if that's equal to x, we pass the second test. And if we pass both tests, then they are inverse functions. Okay, in our previous example, does f compose f negative 1 equal x? Okay. So f of x, which remember, is x squared plus 1 here. Oh, by example, it means this one. Okay. So we're going to have f of x is equal to x squared plus 1. And we're going to have to plug in its inverse here, the square root of x minus 1. So we're going to have x minus 1 squared plus 1. And we're going to put a little question mark here, equal to x. If we can pass this first test and pass the second one, then they are inverses. Okay. So squaring the square root of x minus 1, that's going to be x minus 1 plus 1. And the left-hand side simplifies into x. And since x is equal to x, we pass the first test. And now we have to compose the functions the other way around. Okay. So now we're going to have a function be square root of x minus 1. And we're going to plug in x squared plus 1. Okay. This simplifies into just x squared, since the plus 1 and minus 1 cancel out. And the square root of x squared is x, assuming that x is a positive real number. Otherwise, it would be absolute value x. So we pass the second test. So therefore, these are inverse functions. And if they do ask, here, since it's a square root function, we have to specify that x has to be a positive real number. Okay. And now for the final review. If f of 1 equals 2, what is the value of f of negative 1 of 2? Okay. F of 1 equals 2. And remember what an inverse does. An inverse, it undoes the actions. So that would mean that x and y are switched. Okay. So f of negative 1 of 2, undoing that, we would just get 1 again. That's the answer. Okay. If f of x equals that quantity, what is the value of f of negative 1 of f of f 546? Okay, here We don't actually need to know what this function does. We just have that the inverse in the original function. Since the inverse outdoes the original function, we're going to be left with our original quantity, which is 546, and that's our answer. What is the inverse of 2 over 7x squared? Okay, y is equal to 2 over 7x squared. We're going to change the y into x. X is equal to 2 over 7y squared. Now we're going to take the reciprocal of both sides in order to isolate y. 1 over x is equal to 7y squared over 2. Multiply both sides by 2, and we have 2 over x is equal to 7y squared. Divide both sides by 7, and we have 2 over 7x is equal to y squared. And for the last step, we take the square root. So the square root of 2 over 7x is equal to y. So this is our inverse.